Welcome to Rges Algebra 1. This is lesson 23A, and the sections we're covering are 10.3 and 10.4. Now, this chapter is doing more on operations with polynomials. So if you need some review on what we've already done with polynomials, then you need to go back to chapter 5 and look it over. And I would especially encourage those of you who have joined us at semester to make sure you do that. Now, one of the things that was discussed in chapter 5 was this idea that we could take a trinomial for instance, this, where we have three terms. Terms are sectioned off by a plus or a minus sign, so this would be term 1, term 2, and term 3. And we could convert that, oftentimes, not always, into a product, two things multiplied together, of binomials. And we do that by asking ourselves for the first term, and you would hopefully be already familiar with this idea. If not, you need to go back to chapter 5. But if you are, then what we would do is we would say what times what equals x squared, and we would put that as the first term in both our binomials. And we're asking for a number that would multiply together, two numbers that would multiply together to give me 6, and added together to give me 5. So 2 and 3. So this again is review from chapter 5. Now if we FOILed this backwards, these two binomials, and we multiplied them together, we would use FOIL, meaning looking at the first term in each binomial, that would be x times x. Looking at the outer terms, that means the terms furthest away from each other, and the inner terms, the terms closest together, multiplying each of those and adding them, that would be 3x plus 2x, and that would give me my middle term. And then finally looking at the last terms, multiplying those together, and that would give me 6. So if we took this binomial times this binomial, we multiplied them together using FOIL, we would get the original. So now we're showing you how to work backwards. Starting with the trinomial, how would we get the two binomials? Let me show you one more example here. Let's see. Okay. If we had something like this, and again, if you're not familiar with this, you have to go back and learn these ideas in chapter 5. Okay, two numbers multiplied together to give me 21. They're going to have opposite signs, so that when I multiply them, I'll get a negative, and the sum will be negative 4. So my answer will be, if I have a negative 7 and a positive 3. To check back, I would say first terms, x squared, outer terms, 3x, inner terms, minus 7x, that would be minus 4x, last terms, negative 21. So that checks. All right. Now, what are we trying to do then in 10.3? It says factoring polynomials that have common factors. So we've been dealing in this chapter with common factors. And recall, a common factor will divide evenly into all the terms that we care about. So if we have this example, 3x squared plus 30x plus 448, the first thing I always ask myself, is there a common factor? It means, can I divide something evenly out of all? Well, I could divide a 3 out of the first term, a 3 out of the second term, and a 3 out of the third term. So I'm going to divide that out first. That's always my first step, always. So 3 into 30 is 10x, and 3 into 48 is 16. Now I ask myself, can I divide or factor this again? Meaning, I can't factor the 3 again, but maybe I could factor that again into two binomials. Well, let's see. Do I have two numbers? When I multiply together, I get 16, and when I add them together, I get 10. And the answer is yes, I could go for 2 and 8. Positive 2, positive 8. Don't forget to copy this down. And so that is factored completely. Let's look at another example. My first question is always, do I have a common factor that could go through all three terms? And I do, and that would be 5. So factor out your 5, you end up with 3x squared minus x minus 2. And now I have to ask myself, can I factor this part again? Well, let's try. I would have to have a 3x and an x here. I'm looking for two numbers, multiply together to give me 2. That can only be 1 and 2. And now because I have a coefficient in front of my x term, I would have to take that into account. So if I have 1 here, I'd have to have 2 here. That would be 2x and 3x. Can they have a difference of -1? Yes, if I made the 2 negative. Let's see, I'd want actually the 3 negative, sorry. The 1 over here negative, there we go. Why? Because this makes it -3 in all, plus 2 would leave me a -1 in the middle term. Now check that, always check, FOIL. 3x squared minus 3x plus 2x is minus x and minus 2. Okay, so that works. Always, always check that because it's very easy to confuse the signs and that kind of thing. Now, let's look at the next one. What is my very first question always? Do I have a common factor? In this case, I do. It would be 7, and 7 times 9 is 63. This factors, I recognize that, to factor to the difference of, a sum and a difference. Okay, x minus 3 times x plus 3. Why? This is another review idea, because if I FOILed this, my first terms would be x squared. My outer and inner terms combined would be plus 3x minus 3x. So the middle terms drop out when everything is the same except the sign. So I eliminate my middle term, and my last term would be minus 9. So whenever I have what's called the difference of squares, again, this is a review idea, where I have something squared, this is x squared, this is 3 squared, and in between, it's a minus sign, or taking the difference. Whenever you have the difference of squares, you will factor it to whatever that is. That's an x squared. This is a 3 squared. Same thing here. One will be plus and one will be minus. So that's always the way a difference of squares factors. So there's your answer. Let's see what else we could look at. What could I factor out of every term here? Well, I could factor a 3, but I'm not finished. I could also factor an x cubed, because I have at least 3 x's in each term. So that would leave me with x squared, because if I divide this first term, the 3, I'm asking 3x to the cubed times what is 3x to the 5th? Well, I've taken care of my number, and I've taken care of 3 of my x's, so I have 2 more that I need. My middle term, 3 times what is 6? I've taken care of 3 of the x's, or how many more x's do I need? I need 1 more x and y. 3 goes into 45 15 times. I already have 3 x's taken care of over here, but I still need my y squared. So hopefully you see that. Put it on pause and think that through if you don't. Okay. Now, can I factor this again? Well, I would have to have an x and an x. I would have to have a y and a y. I'm looking for 2 numbers multiplied together to give me 15. Their sum, or their, in this case, their difference is 2. So that would be a 3 and a 5. Which one would have to get a positive 2? This would have to be positive. Okay. So I want plus 5y minus 3y. Check it. First terms, x squared. Outer terms, minus 3xy. Inner terms, plus 5xy. That would leave me with plus, sorry, my thing's not writing well, plus 2xy. And last terms, minus 15y squared. Okay, so that checks. Always, always check it, please. All right, so don't forget to carry this down. And that is how that one factors. So for 10.3 then, I'm going to ignore the oral practice right now. You'll do 1 through 49 odd, and we'll assess how skilled you are at this once you get back to class. Now for 10.4, we have another interesting idea that relates to factoring, a new skill regarding factoring. What if I had 2 pairs already factored, for instance, this? Well, these 2 share a common factor. The common factor these 2 groups share is this. So I'm going to pull that out, even though, just like as if it were a single term or whatever, it's actually an expression, but I'm going to pull that out. And what am I left with? I'm left with the x minus the 12. So that's how you would factor that. And let's show it to you one more time. X times x minus 2 plus 6 times x minus 2. These share a common factor. Their common factor is this. So now I would take that out front. And what are the things I need to multiply this by in my first term? The x. And in my second term, I need to multiply this by a 6. So that's how you do this. Now, the third one is the same idea. I'll let you look at that. There's nothing new there. There's nothing new in example 4, except you would have to have a 1. So you can look at that yourself. And let's look at 5 together. That's kind of more interesting. Sometimes I just like to illustrate it this way. What do these 2 share? They share the 2x plus 5. What are the 2 things remaining? The x squared minus 36. This is fine as it is, but I can factor this some more. Why? That's the difference of squares. So change your second grouping here to x plus 6 times x minus 6. So always make sure, in factoring, the key is to always make sure you factor completely. So I don't think you need the oral practice. We're going to do 1 through 59. Whoops, that's not right. Yeah, it is. Okay, 1 through 59. Give it your best shot, following the directions, and we might have to cover a few of those later ones together once you get back to class.